Hi, this is Kim May from the Fillmore Group, and I wanted to thank everyone for joining us today. We put this presentation together at the beginning of the year after having some discussions with some folks around some of the challenges that System Z customers are struggling with right now, which is that over the past year or two, a lot of organizations have gotten very excited about analytics and as a result have gone out and done a lot of hiring and promotion of data science and data scientists. And unfortunately, what we're finding is that the data scientists' understanding of what data is in the mainframe isn't great. And a lot of data scientists are more comfortable with other technologies. And we all probably know that I'm referring to Oracle. And as an IBM business partner, the Fillmore Group would really prefer that data scientists become familiar with what's on the mainframe and how to access it so that they can get closer to and have better access to that data that usually originates with transactional data, which is really, in a lot of cases, the most important data that any organization is generating. Frank Fillmore is a DB2 Gold consultant. He prepared this presentation and will be delivering it. Are you ready?
I am ready. Thank you,
Okay.
Kim. So welcome, everyone. I wanted to let you know that this webinar is being recorded. It's going to be posted after the fact, so if you have any colleagues that you think need to see the material. Also, the slides that I'm presenting from today will be posted on the Fillmore Group's blog in a couple of days, so you can download those if you want to review the material. This is the first time we're giving this presentation, but as Kim said, we both thought that there was a need for this type of introduction to non-mainframers of what mainframe data is and ways to get access to the data. We have everyone on mute right now. I'd like an interactive session, but I have found that there is an enormous amount of ambient noise with open mics. I was doing a webinar yesterday, a class just for 11 people, and there were barking dogs in the background. So there are a couple of ways that we're going to handle that. Number one is I am going to look for raised hands. That is one of the icons on your instrument panel for the webinar. So if you have a question, if you raise your hand, may not get to it immediately, but I will be able to call your name and open your mic individually when I get to a place where I can pause, so we can take those questions. And then at the end, if we have some time left over, probably open all the mics and we'll just have a free-form discussion if time allows. So we'll play it by ear, but would encourage your questions. As I say, it's the first time we're doing this presentation, so if there are things that are not clear or things that I can help you understand better, I'd like to know what they are. So with that, we're going to go ahead and kick off. So our agenda is to talk about the types of data that is available on Z systems, and we're specifically talking about the ZOS operating system on mainframes. You can, of course, run Linux on System Z. We're not talking about Z-Linux at all. That's just another non-ZOS platform from our perspective. But specifically ZOS, the traditional mainframe that we've known and loved from the System 360 back in the 1960s that IBM made available almost 50 years ago. We're going to talk about the types of data, the primary types of data. And the other thing that I want to tell you about this presentation is that we're going to cover a lot of ground very lightly. Nobody is going to come away being an expert on how to get data out of DB2 for ZOS. The purpose of this presentation is to give everyone a hunting license, so you can know that there may be features and functions that are available and set you on the path either with folks in your shop or other resources available on the web to find out more information. If you hear something today and you say, that's what we need something that does that. So this is a survey presentation to let you know what the options are. So the types of data that we're going to talk about are DB2 for ZOS, which is a traditional relational database management system, IMS information management system, which is a hierarchical database used for transaction processing, and VSAM, virtual storage access method, which is an index file system. The key approaches to unlocking the data are the hybrid transaction and analytics processing, or HTAP, which is a term developed by Gartner. This is not a product that's available from IBM, but this is an architecture that we're going to discuss and a specific implementation on the ZOS mainframe. We're going to talk about replication and virtualization, the ability to copy data from one place to another from ZOS onto a heterogeneous data store. Could be Oracle, could be Hadoop. And virtualization, the ability to use either SQL or non-SQL APIs to be able to get access to the data. And then finally, extract, transform, and load. This is probably the most common form of data management for analytics that we've been using in some form or another for the last 20 or 30 years of taking data off the mainframe, scrubbing it, putting it in a star schema, moving it to another platform, and then analyzing it there. So we'll talk about all four of those. The presentation, again, is directed towards non-mainframe people. I've looked at the job titles of the folks who registered, and they're split pretty evenly between people who are IT architects, data scientists, and so forth, and traditional mainframe systems administrators and DBAs. So you're welcome to be here. You may hear a lot of stuff that sounds very obvious if you come from a mainframe background, but hopefully you will learn too about some new opportunities and some new ways of getting access to this data. Kim introduced the Fillmore Group. We are in our 30th year. We are based in Maryland, but deliver IBM analytics, services, software sales, and training on this planet. We've been a business partner since 1989, delivering IBM education. I'm what's known as a DB2 Gold consultant, and Kim and I are both IBM champions. And the three legs of our business right now are the technical support and consulting, implementing some of the solutions that you'll see here today, an authorized training partner, and an IBM software reseller. So we try to offer a complete package to help you implement IBM technologies. That's a picture of me at the Almaden lab that Kim took that she really likes, that end up in most of our presentations, and is a prime example of why I need to lose some weight. Did you have a comment, Kim?
Yeah, one of the things that I wanted to throw in there about the Fillmore Group is one of the things that we are finding, a lot of our peers are our age, and we aren't children anymore, and we believe that it's extremely important right now for people that are using the mainframe and are still involved in mainframe technology to help younger people and people that are trying to expand data utilization by educating them. And so one of the reasons we're doing this is, and we hope that people share this. We understand there are lots of other people that understand this and get that there's a shortage of people coming out of college that are saying, I want to be a mainframer. So anyone who's on here, no, I'm serious, anyone who's on this presentation who is a DBA or a systems programmer or someone who is dealing with mainframe customers, please feel free to share this, and please make sure that we get the dialogue started in any way that we can.
Thank you. Good comment. So the first data store that we're going to talk about is DB2 for ZOS, version 11, the most current version. Version 12 is in development right now. It is a traditional relational database management system, primarily structured data that is stored in tables using rows and columns. So SQL Server, Oracle, MySQL, you name it, all examples of a relational database. The application access is through a structured query language, SQL, using the current ANSI standard of 1999 with extensions. The primary mechanism for speeding access to the data are B-tree indexes. Key values followed by row IDs that point to the data page and the location of a particular record that has that key. So I could have a unique index on customer number, I could have a non-unique index on last name. And so if I had a last name of Fillmore, I would see the key value of Fillmore in the index, and then all of the row IDs for all of the Fillmores that were in that particular table. Finally, and the most important distinguishing characteristic of the data stores that we're going to talk about today is the cost-based optimizer that chooses the access path. So in the SQL, you describe what it is that you want, and the optimizer decides how you go and get it, whether or not you use an index, whether or not you perform a sort, and all of those types of things. So this is what DB2 for ZOS looks like. There are a series of applications. Application interfaces use standard SQL dialects. And then there are a series of other utilities and tools to load data and unload data, commands to start and stop the database, to make table spaces available. So on the left-hand side, you would see the applications. And in the beginning, these applications were written to run on the same platform as the database. So the applications were written in something called CICS, which is Customer Information Control System, or teleprocessing monitors like that. I would have COBOL batch programs all coexisting on the same server. That is not as true today. Just did a call yesterday with a large Eastern regional bank that does a lot of their application development off-platform using Java. Use WebSphere application server to be able to access DB2 for ZOS data and make it available to customers via web browsers. So very common, but the common theme here is SQL and metadata that's stored within the database. So I describe the table definitions and the column definitions and so forth within the database. Now, how do I get access to this database? Well, one is a feature known as DB2 Connect. DB2 Connect is a long-standing product that was originally developed as something called DDCS, or Distributed Database Communications Services, DDCS. The idea was that I have applications, whether they are coded applications in Java or some other language, or just access via Microsoft Access or a spreadsheet that can access the data in DB2 for ZOS. And the primary function, not the only function, this is an oversimplification, but the primary function of things like DB2 Connect and the data server drivers that you see on the screen are to do EBCDIC to ASCII or Unicode protocol conversion. Data is encoded on the mainframe using, again, in DB2 for ZOS, primarily, although not exclusively, in EBCDIC. So I need a way to translate that data and get it into another format. I can use DB2 Connect, or I could use either of the other two products that you see there. Is the data server driver for JDBC and SQLJ, or the data server driver for ODBC and CLI. JDBC is dynamic SQL embedded in Java program. SQLJ allows me to compile and create a bound access path using the database optimizer that can be used over and over again. So I get very fast repeated access to my data in DB2 for ZOS. ODBC and CLI, dynamic SQL from a variety of different sources that support those APIs. The last item down here is relatively new. It's known as the DB2 adapter for ZOS Connect. This is something that is available for free. This is not a word that you hear, a four-letter word beginning with F that you hear all the time associated with IBM products. But it is available within WebSphere or CICS or IMS. The primary purpose of ZOS Connect overall, not just the DB2 adapter, but overall, is to expose data on the mainframe, whether it's IMS, and we'll talk about IMS in a little bit, or DB2 for ZOS, to JSON, to JavaScript object notation, and use representational state transfer, RESTful services to be able to access this data, primarily for mobile and cloud connectivity. So if I want to have people be able to access their bank account from their mobile phone, I may use the ZOS Connect capability as a way to do that, as opposed to what folks have done traditionally, which is used to DB2 Connect or the data server drivers. Now, once I have that path, if you will, into the database, any of the items that I described, DB2 Connect, the data server driver, ZOS Connect, depending on which of those access paths I choose, I can use these scripting languages, PHP, Ruby on Rails, Python, Perl, Node.js. I could use Hibernate, or Abatis, or other IDEs, development environments for creating applications. I could use the JSON that I just talked about for Microsoft, the .NET data provider that is embedded in Visual Studio, or application servers like WebSphere that allow me to connect to the data via browser on the client side through the WebSphere application server mid-tier, and then accessing the host using one of the connectivity options that I've just described. Now that's all well and good, and people have been doing this for years. The problem, oh, and this is a graphic of the DB2 adapter for ZOS Connect. So the RESTful JSON would come in through the left, it would go through the DB2 adapter, and then it would use JDBC to access DB2 on the back end. Now, the problem that we have in this case, or the challenge, is that most of what I've just described are used today and used very successfully for transaction processing. I need to look up a bank account. I need to do a credit card authorization where I'm supplying something like the account number, the amount, the expiration date, and get back an authorization code. So very small, very compact, very little data transfer between client and host applications. Where this breaks down is if I want to scan billions of rows, and that's what data scientists and IT architects are doing today. The primary means that they have used to accomplish that to this point is to move the data off platform. Because of the usage patterns being so radically different. For example, B-tree index is great when I want to look up one record. B-tree indexes break down if I have to scan millions or billions of records. I probably won't look at the index at all. Or even worse is that my index will grow so large I waste a lot of I/O walking the index levels. If I have billions of rows stored and I'm using the key value RID pairs that I described before, it becomes very difficult and time consuming and takes up a lot of space on disk just to create indexes for tables that large. And then finally, zSystem's disk storage cost is not inexpensive. What we are seeing in terms of applications is especially from the perspective of data scientists and IT architects, the more data, the better. The bigger the data set that I can get over a period of time or at a greater level of granularity, I can get better results. I can get more accurate results. I don't need to do data sampling. I want to be able to see the last 7 years of activity, whether it's stock trades or banking transactions or retail sales, market basket analysis, you name it. That can be very expensive to store that much data on spinning disk on System Z. So we have the problem of interfering with transaction processing, different workload specs. We don't want somebody to wait 2 minutes to get their account balance because somebody's running a query to examine 7 years of transactional data. So the methods that I have described are available to get point pieces of data, but really aren't well optimized for a large-scale data analysis. So with that, before I go into the next section, I do have a question posted here, so let me see that. A question from one of my DB2 Gold consultant colleagues, Richard Winter. Is this available later on? And the answer is yes. We're going to have this posted on the Fillmore Group's blog in a couple of days, probably early next week, both the presentation materials and the recording. So let me go ahead and continue. So one way to deal with the challenges that I've just described is the HTAP approach, Hybrid Transaction Analytic Processing, HTAP. That is a term coined by Gartner that describes heterogeneous platforms, that's the hybrid, both serving in a unified fashion to enable both the transaction processing, the credit card authorization and the lookup of one account, along with analytics that allow me to do deep dives on billions of rows and pieces of data. So IBM instantiates the HTAP architecture on ZOS with something called the IBM DB2 Analytics Accelerator, the IDAA. So it's a product that I believe was originally released back in 2012 and has been going gangbusters. Kim and I have worked with a number of different customers, primarily in the financial services industry, but there are use cases in retail, insurance, and so forth, for the ability to do analytics on near real-time data. Why do we care about that? Well, instead of moving data to another platform and in 2 or 3 days discovering that a transaction was fraudulent, wouldn't it be great to catch that fraudulent transaction at the point of sale system and stop it before it starts?
And so one of the things that is interesting to me with the HTAP is that the term HTAP was coined by Gartner in 2014. IBM introduced the DB2 Analytics Accelerator in 2012. IBM has since also, on the distributed side, they've introduced DB2 Blue, which is another similar HTAP technology for the distributed side. And then obviously other vendors have their own HTAP solutions right now. And what we're seeing is that the technology is catching up to needs. I mean, 10 or 15 years ago, if you wanted to run both, you would very logically move your transactional data off the mainframe and move it to a data warehouse or to a data mart. And now we're seeing, because of the improvements of technology, we're seeing the ability to actually reconsolidate. And it's a totally different paradigm, but it's really something people were trying to do 20 years ago. So it's sort of the way things, the more things change, the more they stay the same.
Absolutely, and thank you for that elaboration. The HTAP technology is really gaining traction with the IDA on the ZOS mainframe, because for many years IBM told its customers the best way to analyze your data is to take it off the platform, and now they're saying no, wait a minute. We can keep it on the platform image. The IDAA is actually the combination of the DB2 for ZOS that we saw a couple of slides ago, and what is known as the Pure Data for Analytics, or the PDA, also built on the Heritage Netezza architecture. So there is a very fast private network that binds these two boxes together, and virtually seamlessly, you can issue a transaction. As a matter of fact, I'll go to the next slide, which actually shows you what I'm about to describe. The application would be running here on the left, and it would vend through the SQL interface a requirement to retrieve some data, and that would go to the DB2 for ZOS optimizer. At that point, the optimizer could make a decision, could actually do it at bind time, not when the application is running, but when it is bound, to say, DB2 for ZOS can handle this very easily. This is a credit card authorization. There are only a few pieces of data. It's an account lookup. I'm going to go and get it and vend the data back to the application. This is the way DB2 for ZOS has worked since it was originally released. On the other hand, if we follow the red line here on this screen, the application goes to the optimizer, and the optimizer says, based on the characteristics of the data you want to retrieve, size of the data set that you want to scan, the size of the answer set that you were anticipated to bring back, and a variety of other factors, I believe I can get that data for you faster by not vending the data directly from DB2 for ZOS, but actually offloading that query to the IDAA, the Netezza PDA that is attached to the right-hand side. There are a couple of names for the same thing, and folks might have heard different names at different times referring to the IDA. So Pure Data System for Analytics, PDA, and Netezza all mean the same thing in this context. But the query actually gets shipped off to the Netezza box. The Netezza has either a copy of the data or more data, a superset of the data that is contained on DB2 for ZOS. For example, I may have 1 year's worth of data available on DB2 for ZOS. I may have 7 years or 10 years of data, or I may have data at a lower level of transaction granularity stored on the Netezza. The Netezza has its own disk drives, its own CPUs, something called an FPGA, a field programmable gate array, and so that query is offloaded and brought back. The design point that is important to understand here is that the application is unaware that this is happening. So for traditional DB2 for ZOS applications, you can do real-time analytics on vast amount of data without having to change your application and without having to go through a process of moving that data, quote unquote, off platform, because the HTAP is a unary platform. Go ahead, Kim.
So where you see, in organizations where they have a standalone Netezza, or there's a lot of data that's moved off to Teradata, this was IBM's way of saying, okay, we're basically taking two pieces of hardware. We're going to take the mainframe and we're going to take a Netezza box and we're going to bolt them together. So this was sort of the first hybrid, and it really is two pieces of hardware. So when you're looking at someone is saying, okay, well, that's data that's coming from the mainframe, and it seems like in this, it's in this amorphous, where is it place? If you've got data that's stored in Teradata, it probably originated on a mainframe. So this is just the bolting them together option.
Exactly. Thank you. Thank you. So in terms of how does this benefit you, the numbers are pretty staggering. You can see some queries. This is from one of the earliest versions of the IDAA. Queries that had run in 2 hours and 39 minutes. You can see query one from the chart that we have up now, ran in 5 seconds. So orders of magnitude better performance. And the most common thing that happens when a customer uses an IDA on their own data, when the query comes back that quickly, that they think something broke. They just don't. It is a feeling of disbelief. What we're seeing is a lot of customers are now able to run queries natively on the mainframe, not interfere with transaction processing, but get data for queries that were denied by the resource limit facility. The RLF said you just can't run. You're exceeding the thresholds that we've set. So people are able to do things today that they just couldn't do before, like in transaction fraud detection and analytics. Now, this next slide I am going to present to you. This is not hot off the presses because it's never made it to the press yet. This is a direction, a research project that IBM is heading in. I can't even use the code name that IBM uses internally for the project. But the difference in the design point here is that IBM is going to incorporate into the PDA box the capabilities of Spark. So Spark is a distributed cluster of machines that supports resilient distributed data sets, or RDDs. And the purpose is to primarily exploit memory as opposed to the MapReduce paradigm, which primarily focuses on distributing data on disks. So to overcome some of the limitations of the MapReduce paradigm, Spark is sort of the next generation of how I handle huge data sets and get queries back in seconds or sub-second response time. So the important thing to understand here, and the big difference between the IDAA that is available today as a product and the direction that IBM may or may not take, there is no guarantee that this product will ever see the light of day, is to incorporate Spark into this platform and then make available through a variety of different APIs that are not SQL-based, that won't go through the DB2 for ZOS optimizer, will go directly to the data on the IDAA platform through Java, Scala, Python, and so forth. So you'll still have the protection, the high availability, the security of the mainframe, but you will be able to use non-SQL access to Spark running in the IDAA on the data that represents what was originally not only in DB2 for ZOS, but also IMS and also VSAM. We're going to talk about IMS and VSAM in more detail. But the IMS and VSAM data will be taken as snapshots and loaded on a periodic basis. So once a day, I'll be copying the IMS or the VSAM data into this system, but be able to run my queries on all of that data combined together. So basically all of the data, virtually all of the data that's available on ZOS today will be available in the IDAA, and you can access it one of two ways: through the traditional IDAA SQL API or through the other non-SQL access using Spark. So we're going to shift gears here for a second, and we're going to look at another data management methodology within the ZOS operating system known as IMS. So IMS even predated DB2 for ZOS. Hierarchical data model, typically accessed through third-generation languages, COBOL and PL1, embedded data language interface called DL1, multiple fields combined together, so name, address, phone number, city, state, zip, are combined together into a record type, or known as a segment. So very much equivalent to a row and columns in a relational database. Segments and fields are the equivalent in IMS. Applications navigate between segments using embedded pointers in the traditional IMS methodology. So here is an example of a hierarchical data model. So I could see the subject area 1 of physics, the authors who wrote books about physics, and the books that they wrote. So author 1 wrote 3 books, books 1, 2, and 3. The subject area 2 is basket weaving, and author 5 also wrote 3 books about basket weaving. So this is an example of the way that the hierarchical model would be instantiated within IMS. So how do I get access to IMS data? One is to extract it natively on ZOS, and this is the way people have been doing it for decades. They write a custom program. They write a COBOL program that actually extracts the data, writes it to a flat file or a sequential file, and then moves it off a platform using something like FTP. So technologies that have been around literally for decades, and people started doing this because there was no other way to do it, and they've been doing it the same way successfully for years. The other extract natively on ZOS is using a utility like FileAid. There is the IMS Enterprise Suite that allows for APIs like Microsoft's .NET, Java, and SOAP to be able to get access to the IMS data. And then the ZOS Connect that we talked about before, primarily for mobile and cloud, being able to run in the Liberty profile within WebSphere, being able to get access to the IMS data. The next set of data that we're going to look at is VSAM. Now, both DB2 for ZOS and IMS are what are known by IBM as licensed products. You have to pay money to use them. The ZOS operating system can run fine without them. That is not true of VSAM. VSAM is integral to the operating system and is used in some shops in place of any data management system like IMS or DB2. They come in different VSAM files, virtual storage access method, comes in different flavors. There are the entry sequence data sets, the key sequence data set, and the relative record data set, the ESDS, KS, and RRDS. The one that is primarily used in applications, and again, I'm drawing a broad oversimplification, the one that is primarily used in applications is the KSDS. So I would use a key such as the account number or the purchase order number or the patient ID or the SKU or something like that, and I would look up the record. And I would be able to find the record that is associated with that key and get all the data that I need. This too is typically accessed via a 3GL, so COBOL or PL1. Been running programs for years accessing VSAM data. Could use a teleprocessing monitor like CICS for transaction processing to be able to access VSAM data. The biggest difference between the first two data sets of data components that we have discussed and VSAM is that the metadata, the data about the data, is very rigidly structured in DB2 for ZOS and in IMS. That is not true of VSAM. VSAM embeds the schema in application programs, typically through something called a copybook. A VSAM file will have a series of fields. The fields will be described in terms of length and data type using in COBOL picture clauses, and you would store that copybook. Any program that accesses that file would use that copybook. If the change occurs to the file, all of the programs need to be recompiled with a new copybook. So much more difficult management problem for what we call schema evolution as the data changes over time. The other big challenge with VSAM is that a single file may have multiple schemas. So instead of the normalization that we go through in a relational database, I may have embedded in a single VSAM file both the purchase order header information, the vendor, name, address, phone number, city, state, zip, and at the same time in the same file the purchase order line item, which contains line item number, SKU, quantity, amount, extended amount. So I would need to read the file and know by some indicator embedded in the file. This is a record type H for PO header. This is a record type I for purchase order line item. So it makes it much more difficult to extract data, and that's why I have down here the designation of dirty data. The fact that the other is that the data conventions are weakly enforced. You can, for example, find lots of non-numeric data in numeric fields in VSAM files. You could find dates like April 31st and a number of other different data anomalies because of the way that schemas are managed and the fact that bad data can get into a file over time. So this is what VSAM would look like from a structure standpoint. You can see the KSDS in the middle. There is an index component that accesses the data components. So if you're doing an index lookup, you can find the record that you need. Now, how do I get access to VSAM data? Typically, I would extract it natively on ZOS. I would write a program. I would write a COBOL program that would read the VSAM file and export it to a sequential or a flat file. I could also use the IDC access method services repro command. IDCAMS is a utility, and I would use that utility to create a flat file and FTP it off. And again, people have been doing that for decades, and it's a very common method, but a time-consuming, expensive, and error-prone. Now, there are a series of methods for accessing the data that are common to both IMS and VSAM. One is replication. The ability and the product that instantiates replication is IBM InfoSphere Data Replication, or IIDR. And the second method that we're going to discuss here is virtualization, the ability to use either SQL or non-SQL access to a variety of different data sources. So for example, IMS, VSAM, DB2, but also many others on other platforms. The ability to issue an SQL command and real time get access to the data where it resides and have the virtualization server be able to translate that data from VSAM into a format that can be consumed by the application that's requesting it. And then finally, both IMS and VSAM data are available on HTAP. So one of the things that I want to do before I continue, this is the summary part for IMS and VSAM, and then we're going to translate into the data access methods that I've just described at a high level. I have a series of questions that I'd like to ask. So I'm going to open our first poll. The question is, the first one is, how is the data stored in your shop? And I'm going to go ahead and launch that poll. And if you could take a moment, you should see the poll arrive on your screen. If you could tell me if your data is in DB2 for ZOS, IMS, VSAM, DB2 for Z Linux, or others such as Hadoop, Oracle, etc. So we'll give folks a couple seconds to do that. So most of the shops have both DB2 for ZOS data and then others such as Hadoop, Oracle, SQL, etc. About 50% of the shops have IMS. And about half of you have updated your poll, so we'll give you another minute to do that, and I have another poll following. And I want to thank Kim for putting together this poll. Okay, thank you very much for that feedback. I'm going to go ahead and give you another more second. I want to at least get 50% of the responses back. So we're going to go ahead and close that poll. And then I'm going to open a second poll. And it says, so equally important to knowing what data you have is who controls the access to it. Who controls the access to the mainframe data in your shop, whether it's IMS, VSAM, DB2, any of the above. So I'm going to go ahead and launch that poll, and if you could take a second. And by the way, there's one answer on here that I hope we don't get a response to, but you never know. Actually, we do have some Attila the Huns, yes. So the data security team. And so Kim, you have a comment?
Yeah, one of the reasons we put this question out there and included this in the presentation was that one of the challenges we're hearing within organizations is that the Z team have usually been in place in an organization for many years, and in a lot of cases they're sort of isolated from the rest of the organization. And if you're a data scientist or you're somebody that has been tasked, or you're an analyst and you've been tasked with doing some form of analytics on the mainframe, they may not be the easiest team of people to work with. And so one of the things that we're helping to facilitate with this presentation is to start some discussion. And we don't want data scientists and we don't want analysts to feel that the data that's on System Z is not available to them. It certainly should be. And as you can see, there are plenty of tools to get to it.
Perfect. Thank you, Kim. So we're going to go ahead and close that poll, but about 25% said the database manager, 63% said you had a data security team or a data security function, which makes perfect sense. And in some ways, that would make it easier to get access to the data if you have a specialized function that just focuses on that. So I'm going to go ahead and close that poll. Thank you very much for participating. So we're going to roll ahead now, and we are going to describe each of the types of functions that you can see there: replication, virtualization, and then back to HTAP. So we can say, once you know what data is out there and how it's formatted, how can you get access? Oh, and I forgot the fourth method, ETL, the ability to use extract, transform, and load. There will be a poll later that actually asks you which of these methods you use after we describe them. Pardon me. But the ETL is a classic method of extracting the data. Comes in a bunch of different forms. IBM's Data Stage is an example of a product that does that. It's known formally as InfoSphere Information Server, using the classic connector for ZOS, so I can get access to my IMS, VSAM, and DB2 for ZOS data. Just want to go back for a second. The two products that I didn't mention under virtualization, I do want to call them out by name here. One comes from IBM, called the InfoSphere Classic Federation for ZOS, which provides SQL access to both relational and non-relational data like IMS and VSAM. And then Rocket Software's Rocket Data Virtualization Server, and that provides for both SQL and non-SQL access, or no SQL access. And then finally, there, in terms of ETL, there are a bunch of third parties out there, Informatica and so forth. So I don't want to limit anybody. It's just, we didn't want to create laundry lists. So this is a little bit deeper dive into IBM InfoSphere data replication, or IIDR. IIDR is primarily a log-based capture that allows me to copy data from something like DB2 for ZOS in the recovery log, and then vend that data to a variety of different targets. So you can see I could copy data from DB2 for ZOS and replicate it to another DB2 for ZOS or DB2 for LUW, Informix, Oracle, SQL Server, Sybase, as well as message queues, flat files, Hadoops or streams, and then that data can be available to applications like the Hadoop distributed file system or Hive, MySQL, Enterprise DB, Greenplum, you name it. So I can copy the data. The benefit of replication is I'm getting access to the data near real time. We've worked in a bunch of shops that have used this replication paradigm, and they exhibit anywhere from 0 seconds to 2 seconds latency, meaning that 2 seconds after the data is committed in the source or transaction processing server, it can be available in the target server of your choice. So near real time access to the data. I mentioned DB2 for ZOS is log-based. IMS is also log-based capture, and the VSAM that you see down here, VSAM doesn't contain a transaction log by itself, so it uses facilities provided by CICS, the Customer Information Control System, that allows you to record the changes that have occurred to VSAM files and be able to replicate them off. So all three are available near real time on other platforms. So replication strengths, typically log-based, and I can isolate analytics from OLTP on a different platform. This is the move it off strategy. This is what basically IBM has been telling their customers for decades. Put it on another platform. And if your business requirements say that I need to be able to do my analytics on near real-time data, then replication is a viable alternative. The weaknesses. There can be some data conversion issues. The EBCDIC to ASCII or Unicode protocol conversion, different databases handle things differently. So for example, nulls are handled differently in DB2 for ZOS than they are for Oracle. For example, I can have a not null variable character field in DB2 for ZOS of 0 length. A not null variable character field of 0 length in DB2 for ZOS. I can't do that in Oracle. Oracle automatically converts that to a null. And so if I'm using the same schema as I have in DB2 for ZOS, and I try to recreate that schema in Oracle, and I say this field is not null, and I try to replicate data into it, it will fail because it says this is null, and you said not nulls because it's a variable character field of 0 length. So there are those types of gotchas when I'm moving from one database server to another or from one platform to another. The other is that latency can become an issue. So I know that on typical transaction processing, my data can be current as of a couple of seconds. However, if somebody cuts loose a batch job at night and they update 100 million rows and only do a single commit in DB2 for ZOS, we have what I call the elephant in the snake problem of a huge amount of data, a program that might have been running for 30 or 40 minutes, and then all of a sudden 30 or 40 minutes of updates need to all get shoved down the pipe and replicated to another platform. And that can be very time consuming and expensive. So you can see wide variations in latency. The other and final weakness is limited data transformations. So I can change the data somewhat. I could lengthen a field. I may be able to change a data type. But natively within a replication product, I'm not going to do massive transformations of data, taking a transaction processing system and making it a star schema. So that's replication. Federation, on the other hand, says instead of making another copy of the data and putting it someplace else, I'm going to go get the data where it is right now. So the virtualization, which is a generic term like HTAP, is instantiated from the IBM perspective via the InfoSphere Classic Federation for ZOS. So this allows me to run an application that I have up here on the top screen, could be on any of these platforms, AIX, HPUX, Solaris, etc. It is an application which is running SQL. This is the IBM product that only supports the SQL API, but allows me to reach out to all of the back-end data sources that you see there. IMS, some heritage database management systems like IDMS, DataComDB, Database, and VSAM and sequential files. All of those will be mapped using the metadata catalog populated by someone working with a classic data architect that would map saying this field, this positions 1 through 5 in your VSAM file is actually the purchase order number, and that will get stored in the metadata catalog. So when I issue my SQL statement, everything will look like it is in a relational format, and so I can get access to the VSAM data or the IMS data, etc. So the good news is I have real-time access. I have access to the system of record. The bad news is I have access to the system of record, and I go back to the problem that I had in the very beginning with my data server drivers in DB2 Connect, in that my access may interfere with transaction processing. So the strengths are the real-time access. That's supposed to be system of record, not system or record. And the weakness is interferes with OLTP. There may be some data conversion issues like there were with replication. However, we're not landing the data anyplace. We're not putting it in another database. It is being accessed by an application. So it's going directly into the application in whatever development language you're using. And again, limited transformations, especially for the SQL-based access. Finally, extract, transform, and load. So I stole this slide from an IBM fellow named Namik Hurley. He's a guy and a fellow That's the highest level of technical attainment within the IBM company, and he has designed a lot of the HTAP facilities as well as lots of other products for IBM over his career. But this shows what happens with extract, transform, and load. And this, again, is a decades-old methodology for getting data from the online transaction processing system that we see over the left to staging areas, operational data stores, enterprise data warehouses, data marts, etc. So I am making lots of copies of the data. There are lots of ways to do this with DataStage or Informatica, etc. But the bottom line is the strengths and weaknesses are as follows. I can have unlimited data transformations. That's one of the things that DataStage does great. And I can isolate the analytics from the OLTP on a different platform, which was why it was devised. The weaknesses are typically cost. So a statistic that jumped out at both Kim and me that we saw in a presentation on System Z. You want to take this, Kim?
Yeah, IBM came out with a stat last year that said that between 25 and 40% of an organization's data costs come from moving data from ETL and from replication. And so one of the things that needs to be taken into consideration when you're looking at how am I going to access mainframe data is what is it going to cost me? And I think one of the things when we hear from analysts and they say we went to the System Z team and we said we need this data and we need it really fast and we need very low latency and then the Z system team was not very excited about making that available to us. And usually that comes down to that C word. It is cost. It is almost always cost. And people will come back and we will talk to customers and we'll say, well, then we have to do less replication and less ETL and can't we leave the data in place? And you'll find out that, well, we have invested heavily in Teradata, or we have this huge data warehouse infrastructure set up. And so it's something to keep in mind when you're talking to people. A lot of times it does come down to cost, and every time you want to move your data and make another copy, there's a lot of costs associated with it.
Thank you. That's excellent. The two other items that are weaknesses here that we need to emphasize are latency. The ETL process could extend the latency by hours or days. So when we get back to the in-transaction analytics and the ability to stop fraud, I want to do that at the POS terminal. I don't want to do it 3 days later in the data warehouse and say, oh, that transaction that we approved 3 days ago is bad data.
And we never hear an analyst that says, I don't need fresh data. They're always talking about how, no stale data, no stale data. We know it's important. It doesn't make any sense to use old data.
Right. So reducing the latency is extremely important. And then there is the complexity risk, the data provenance and the security aspect. So you can see the data provenance. By the time the data gets down in the data mart, it would be very difficult to determine exactly where that data originated. When the vice president of marketing points at a pie chart and says, I think that percentage is wrong for my product line, where did that number come from? It might take somebody a couple of days to figure out, to be able to go back and get access to the original transaction processing data and all of the problems that we've seen before with data warehousing and ETL of aligning data that uses different calendar periods and things like that, something done weekly versus monthly and so forth. So I think you're aware of the problems. And also finally, security. By moving the data off platform, the more copies you make, the more potential there is for a breach. In a lot of the data breaches that we've seen, it is not the core system of record that's being hacked, but a secondary system where the data has been moved for analytics or other purposes.
Yeah. And just one other comment. You will hear mainframe people talk. One of their key selling points for the mainframe is always that it's the most secure platform. It's very secure. Unfortunately, I don't think I know of a single mainframe shop right now that isn't replicating some of their data, at least some of their data, off the mainframe. So when somebody gets hacked, it may not be the mainframe being hacked, but every time you make a copy, you're opening up the potential risk.
You're opening up another door. That's exactly right. So what I wanted to do in summary was go back to the HTAP, the Hybrid Transaction Analytic Processing that IBM vends as the IBM DB2 Analytics Accelerator. And the value prop is that the HTAP reduces ZOS CPU utilization, which is a target for a lot of CIOs all over the place. The mainframe is expensive. We either want to reduce CPU utilization or we want to be able to grow without having to add more ZOS capacity. you can reduce the analytics latency. The slide that I showed you of the IBM direction for HTAP in the near term, which is not committed as a product delivery. I need to say my qualifiers. But the analytics latency will be reduced to 0. You will be able to, from the DB2 for ZOS standpoint, if IBM is able to realize its goals, is that you will be able to do real-time analytics on a system of record transaction processing data without latency. That is the goal. You could reduce the data modeling overhead, all the stuff that you go through for star schema. Kim and I worked with one customer that went through a data modeling exercise to build a data warehouse for 1.5 years. They spent 18 months just modeling the data, and that was so they could get access to it in a speedy fashion once they started writing queries. But of course, they had an 18-month lag. Yeah, two years later. HTAP reduces the complexity risk because it's a single platform image, even though it has multiple different components. Reduces your integration costs because the NetEase of the pure data system for analytics is tightly coupled and fully integrated into a single platform image with ZOS. And finally, and this is something that Kim has emphasized in a lot of her presentations, the storage costs. We're looking at what, less than $1 per gigabyte per month in the analysis that you did. It was like 60 or 70 cents. I think that was
gigabyte, but I'm always the proportion.
Right, but the idea is that we have customers who are spending orders of magnitude more than that for spinning disk ZOS storage of their data. So the idea, what I like to say about IDAA is it is online storage of data, and you get the analytics for free. You actually save money just by storing the data that you're already storing, but you get all of the other benefits that we've described. So I'm going to wrap up now. Before I go to next steps, I want to open our last 2 polls. So the first is, which methods are you using today in production? So I know that there are a lot of bake-offs and a lot of test projects, etc. But what are you doing today in production with transaction system of record data to perform line of business analytics? So I'm going to launch that poll. And so any of the methods that we have described here, HTAP, replication, federation, ETL, or other. And then I have one more following this. And while you're doing that, I will talk about the next steps. The next steps are to determine the application requirements in terms of latency. How fresh does this data need to be? There are some things, for actuarial purposes, it doesn't have to be real-time data. We understand that. But if you want to do point-of-sale market basket analysis, it does. There is a customer that's using the IDA HTAP in Europe that will actually, as a customer is buying a market basket of products, will be able to make recommendations for other complementary products that you may want to purchase as well, real time as the customer is pulling out their credit card. You'll need to look at things like the volume of data, the retention period, how long do I want to keep this data for legal and compliance reasons as well as for analytic reasons to see changes over time. What data needs to be used in combination with the ZOS data. So obviously you're incorporating data from other platforms and pulling that together. There may be external data that you are buying or sentiment analysis from Twitter or things like that, other primarily unstructured data that could inform your transaction processing systems, analytics, and then finally the analytical tools that you're using. So interestingly enough, nobody is using HTAP that's on the call today. 50% are using replication and 80% are using ETL, which is exactly as I would have expected it. And then finally, the last poll, do you have a current line of business application analytics requirement? So we'll go ahead and open that up, and I will go to the next slide while you're doing the poll. And it looks like about 2/3. Two-thirds have a current project underway and 1/3 do not. So the next steps, we would certainly like to help you on this journey, choosing the right tool of getting access to this data. There are a variety of different ways of approaching this, from a whiteboarding session, hands-on workshops with some of these tools, a proof of concept where you would actually install software or hardware in your shop and use your data. And then finally, a financial analysis to see what you're spending on ETL tools today and all of its components, and compare that to maybe a different approach. So I think we're coming just at the top of the hour. I want to thank Karen Durwood, Namik Hurley, Jorn Thyssen, and Paul Worth for their contributions to this presentation. Lots of contact information for Kim and me, so you know how to get a hold of us. This will be available at the Fillmore Group's blog, www.thefillmoregroup.com, all spelled out, along with the recording. So in the time that we have left, Kim, do you have a closing comment?
Yeah, just one comment before we go. I just wanted to, for those who are on the call, who are mainframers, who are DBAs by heritage, I hope you have enough information here that when there is another application that comes under discussion, that the first thing you do is sit down with the analysts and sit down with the data scientists and say, hey, look, let me share with you what we have. And I hope this gives you a foundation, or at least a starting point. For those of you who are looking at application development or that are looking to be developing things using some mainframe data, please call on us, or please call on your colleagues in the Z world, and don't hesitate. I think one of the things that we're so afraid of right now is that people are finding other ways around using the mainframe data. It's there and it can be accessed. You know this now. Take this presentation to your Z people and say, hey, look, I saw this, and we'll back you up.
Thank you very much, Kim. Well, really appreciate it. So what I'd like to do is I would like to, we are at the formal end of the program, but I will open the mics for the folks on the call. So we'll probably hear a lot of background noise because that's the way it works. If you have some background noise, if you could please self-mute. But I want to give everybody, we can take a couple of minutes. There weren't a lot of questions during the presentation. If you have any questions, I'd certainly like to hear what they are. So does anybody have any questions? Anything that you'd like me to go over again, a slide? As I say, the presentation materials and the recording will be available on the Fillmore Group's blog probably on Monday. So if you don't have any questions today and you think of something later, please reach out to us with the contact information here. Actually, I do have a question that popped up. Oh, a comment from Tracy. Thank you very much. Great presentation. Go mainframe. Here, here. That's great. Have a happy Friday, everyone. Take care.